check number 2. Look at this review I found for an Apple iPhone, right? Glass breaks easily. So it fell from his lap to the pavement, right? And then it broke right away. And if you do a Google search for this, you find this is a big problem as well for Apple iPhones. But here's what I want to point out. Look at that number. What do you think the Apple marketing department would pay to have 52,000 people not have read this thread and have that perception of their products? The iPhone breaks easily. Even if they fix it in iPhone version 2, you know, they recall them, even if they make them out of iPhone 5s or out of Gorilla Glass, you know, they made a big deal about the Gorilla Glass in iPhone 5, or even if they do that, what's going to stick first? What's going to anchor people's expectations? And if you read that book, Predictably Irrational, it's usually the first thing we see. So 52,000 people, who knows if it's the first thing they saw about iPhones or the first thing they color their expectations. But I bet you the marketing department would pay a lot to have those 52,000 people back. All right? In fact, it got so bad, Apple got sued over it. Now, it's obviously a silly lawsuit. You can't sue products because they didn't last as long as you thought they were going to last. Like if you thought it was going to last 5 years and it lasted 3, there's no implied contract there. So I don't think the lawsuit will go anywhere. But the reason I point this out is look at the very bottom line. The 3G iPhone survived similar incidents with no damage, so in his mind, the iPhone should as well. Again, it might be an irrational expectation. The iPhone 4 is thinner, it has twice as much glass. Maybe it's a harder engineering challenge, right? I'm sure Apple did the best they could. But what are people comparing your products to, right? So watch out for that. That's the expectation people have set. So what could they do about it?
Well, and it also says 20 times stiffer and 30 times harder than plastic.
Yeah, no, that was a big deal. If you look up Gorilla Glass, Apple said, oh, we have this new tough glass. You know, and even giving it a name, Gorilla Glass, they had the specs everywhere. You know, they made a big deal about it. So when it didn't live up to expectations, again, it's setting high expectations and not meeting them is usually the source of bad reviews.
Right. But as an engineer, I look at stiffer and harder and start.
Go ahead, Al.
As an engineer, I look at stiffer and harder and start to worry about durability.
Exactly. Yeah, it gets more brittle, right? You can't have everything. Something gets harder, it's usually more brittle. You're right. Again, if you look at the iPhone 5, it doesn't seem to have this problem. But the iPhone 4, it became a big deal. Like became a big press thing for Apple. So, again, what would Apple's marketing division pay to have those 52,000 views back if they could step back in time? So the question is, what can you do ahead of time? Maybe you take an extra day to do this. What can you as an engineer do? Because really, who's going to check? Is it the marketing division? No. It's the engineer's job to make sure to protect the marketing division, like a football team, right? Everyone's protecting each other. It's the engineering department's job to protect the marketing department from problems like this. So what can we do about this? Well, one thing you can do is you can get a high-speed camera, get 5 or 10 of your models, and go out to a site and go test it. Usually people do this in private. There's a comedy website called The Daily Drop, and they went out there and actually did this for a lot of products for comedic purposes. Oh, I just closed it. Let's see if this can open real quick. And if I have a fast enough connection, I'll show you the iPhone here. Or I'm sorry, the Xbox. We've got a little intro here. There we go. All right, here we go. So Al, is this coming in okay?
Yeah, it is.
Here we go in slow motion. And this is what I love about this site. Watch the front. Al, did that video come in through okay?
Yep, the video came through great.
All right, great. So, yeah, you can do this with your products. You can set up a testing lab, and most good companies already do. But how many of these are you going to test? 5? 10? 20? How many of these are you going to break? And you can put accelerometers on them, you can put strain gauges, but where do you put them? Look at how chaotic this test is. Where are you going to put your strain gauges? How many chances do you have to get oh, they dropped it again. I didn't even realize that. So, okay, now they're dropping it on the back, right? They're trying to get oh, wow.
What I find interesting is the way that flexes looks very similar to a simulation run.
Let's try and get, it's a very non-linear thing, right? So here, let's watch it again. You'll see that that plate flex. So that's a very non-linear thing. It's very dynamic. So the question is, what can we do about it? You could build a 100-year product and test it that way, but in SOLIDWORKS there's a predefined test for this, right? They call this the drop test. So what you do here, I downloaded an iPhone model from GrabCAD, my favorite SOLIDWORKS downloadable website. I put you can see this big battery here that obviously on GrabCAD no one knows what the inside of an iPhone looks like. It's proprietary. So I put this big battery in there. I put it on a circuit board just for just demonstration's sake. Here's the great thing about the drop test in SOLIDWORKS. All you have to do really is put how high you want to drop the part from. You don't have to figure out the 1/2 AT squared. You don't have to figure out how fast it's going when it hits the ground. The hardest part, you don't have to figure out how long it stays in contact with the ground. That's the hardest part of figuring out the force, is force times time equals change in momentum. How are you going to figure out the time? Is it 15 milliseconds? Is it 17 milliseconds? Is it 100 milliseconds? You don't need a high-speed camera to figure this out. That's what the simulation will do for you, right? So really all you set up is the height it drops from. Gravity is always going to be the same. You do a mesh, and what do you get? And you can see here I'm trying to drop it on a corner. A common thread in the Apple forums was if you drop the iPhone on its back or on a flat part, it's fine. If you drop it on a corner, that's when bad things happen. Now that was found through reality. But the point we're trying to make here with simulation is you as engineers can find that before the product ever ships. Before you even make a prototype, you can find out the worst orientation to drop a part and the best. So what does it look like? Now, drop tests take a long time to run, so this one didn't finish all the way through, but I'm going to try and hit play here. Okay? Oops, go back one. And if I let this one run all the way through, you can see actually see the shock wave traveling up the surface. Now, I've got the deflection turned way down. Again, like I said, it didn't finish running. I had to stop it just to come to this webinar. But if we had let it run, you could see the deflection wave go up to the top and come back. We've done that with other drop tests before. All right. And here's a static image of it. Again, look down here in the corner. Look at the microseconds. It's 17.62 change microseconds. That's what I'm looking at the stress at. So it figures out, it takes regular intervals, gives you stress plots at those times, so you can actually see the shock wave traveling up through your part, just like we would have in that video. Pretty cool, huh, Al?
That's actually one of my favorite things about simulation.
Drop test, yeah.
Yeah.
And again, that's doing it. Oh, have you done any cool ones that you can talk about for customers, or any customers we don't have NDAs for?
No, I haven't done many, but I like watching the results.
Yeah, no, they are cool. And this is in the Simulation Professional package, and they're linear results. What they're doing, the reason it takes so long to run, is it's doing very, very small time steps where it can be assumed the change is linear, and it's recalculating the stiffness at every time step. That's how you can get away with doing this in the linear regime. There are non-linear ways to do this. The Simulation Premium package has non-linear solvers. That's how I would do hammers hitting things, bullets, impacts, things like that. I would do them in the non-linear package. Take a lot longer to set up, take a lot longer to run. You really have to be a simulation expert. For the drop test, like I said, it's really easy to set up. You just basically put in the height, and then it calculates the rest for you. Now, everything's not roses here. you do get this is a transient graph of the stress on a certain sensor at a certain time. You can see it stopped at 15. That's where I stopped the second analysis. But what are we saying to do for this? It does take a long time for these drop tests to run. So we're not saying come up with 20 scenarios and run them all. We're saying use this to set up your physical drop test. Use this check to figure out where's the worst case scenario that my part could be dropped at, and where should I put the accelerometers? Where should I put the strain gauges on that specific test? Saves you a lot of time with the actual physical tests, and make sure you don't miss anything. And make sure you don't test the iPhone being dropped flat when the corner is really the big deal, and maybe which corner, right? The insides of the iPhone are going to be more complicated than I made it, so maybe which corner matters. But the one I did get to run, the 17-second one we saw the video for, think back to those 5 tips I put at the very beginning. Think back to working while the iron is in the fire. I ran it last night. So around 8 o'clock last night, I kicked off the analysis, and around 10 o'clock, 11 o'clock this morning, I stopped it and saved the results. Now, I should have let it run for longer. Drop tests can easily run for 24 hours on a slow computer like mine. But the computer was sitting there anyway, right? It was sitting overnight. So why not run it while the computer is just sitting there? Think while the iron's in the fire. Make sense?
Absolutely.
All right.